Hello, so what we see on the screen is a schematic of a circuit which is popularly known as a filter. Specifically, it's called as Salen-Key filter topology. Salen and Key, two people from MIT Lincoln Laboratory, invented and proposed this second order active filter topology based on the impedances that we see here, Z1, Z2, Z3 and Z4. We can use the resistor and capacitor combinations and arrange them in such a way in the circuit so that the circuit can take the form of second order active low pass filter, second order active high pass filter, and using a combination of active low pass and active high pass we can create an active band pass filter, which all will be called as Salen-Key second order active filters. So the basic principle right here is we see you have an input signal V in there, you have an output signal V out, and you have got four impedances Z1, Z2, Z3 and Z4. As I said, these impedances can be implemented using resistor and capacitor combinations. So it is called an active filter because it uses an operational amplifier which has got positive and the negative pins, and the output of the op amp is tied back to the negative pin of the amplifier. So that puts the amplifier to be used as a voltage follower or a buffer between output and input of the circuit. So since the gain of the amplifier right here A is practically very high, ideally infinite, we apply a concept of virtual short that makes the voltage at the negative pin to be equal to the voltage at the positive pin. So that's why if we say the voltage at the negative pin is V minus, that voltage is highlighted at V plus, which is V plus will be equal to V minus. Okay, this is called virtual short concept because the gain A of the amplifier is extremely high, and we see that the output then follows what is available at the input right here. Okay, so what we can see here, when you apply an input signal, that is voltage or current, that has amplitude and the frequency, and depends on the what kind of filter you realize, whether it is low pass or high pass, your output will be in proportion to that. So let's say your Z1 is a resistor, Z2 is a resistor, Z3 is a capacitor, and Z4 is a capacitor. That makes the circuit biased as low pass filter with Salen-Key topology, and from DC up to a cutoff frequency of the input. I would repeat, from DC to a cutoff frequency of the filter as set by the impedances, your signals will be filtered and passed to the output. That is called as pass band of the circuit. But after the cutoff frequency, your signal will be attenuated by the filter and output will be zero. So that's the behavior, typical behavior of low pass filter, where the characteristics will look like this. So you see that somewhere here you have the FC in the middle, and here at this node you have the filter cutoff frequency, and this is your pass band, this is your stop band. Okay, so with that said, we have this filter response,